Welcome to Pre-Cal Trig. We're going to be going over the concepts in Unit 1, solving equations and inequalities. You can use this video as help with the Nearpod assignment that we have at the end, which will count for the Unit 1 test Part 2. So make sure to take notes, pay close attention, and you'll have everything you need to do well on the Part 2 of the Unit 1 test. Please get that done. It'll make a huge difference as soon as it's done in your overall grade. Make sure that you're really getting into our class resources, reading our course announcements, getting into the course, doing all the practice, taking the quizzes, those count as practice to get you ready for your unit tests. Complete every unit test, sign up for help sessions, and drop in during office hours with your questions. You can also take screenshots and send me questions in email. All right, we're going to start with this problem. What is the solution to the rational inequality 2x over x minus 1 less than or equal to 1 over x minus 1? So what we need to do is we need to get everything over to one side of the inequality. So I'm going to choose to subtract 1 over x minus 1 from both sides. So on the left you've got 2x over x minus 1, and then we need to remember to subtract that from the left, 1 over x minus 1 less than or equal to 0. Because we have the same denominator, we can combine the numerators. So in the numerator we have 2x minus 1, and we have x minus 1 in the denominator. We'll set that equal to 0, and we'll look for any zeros or any extraneous solutions, or where x minus 1 would be 0. That would give us an undefined solution. And then we'll plot those on the number line. So we'll start with that undefined solution, x minus 1 equals 0. Solve for x. X is equal to 1. Alright, so we'll put that on the number line. And keep in mind that this is going to be a place that we mark, but we know that we can't have a solution there, so it's going to be an open circle. Now we'll look at the numerator. Now the numerator can be 0, so we'll look where that can happen. 2x minus 1 equals 0. And then we'll add 1 to both sides, and we'll get 2x equal 1. Then divide by 2, and x is equal to 1/2. Alright, so we'll go over here to 1/2, and we'll go back up here and look at our inequality. We have that less than or equal to, so we're going to go ahead and color in this solid dot right here at 1/2, because we can't have a solution at x equals 1, but we will have an equal to a solution at x equals 1/2. And now we divide the number line into 3 distinct areas. This area right here, we'll call that area A. I'm going to pick a number that's in this area, and I'm going to find one that's easy for me to use, so I'm going to stick with 0. If you substitute in 0 into the inequality, or let's just use where we simplified this, let's plug it in here and see what kind of an answer we have. Alright, so if we put in 0 here, 0 times 2 is 0. 0 minus 1 is minus 1. And we put a 0 in here, 0 minus 1 is minus 1. A negative divided by a negative is a positive. So we just need to find out what kind of answer we have. So our answers here are going to be positive. Okay, now let's look at this middle part right here. It's going to be a little more challenging. We need something in between 1/2 and 1. So let's pick 3/4. And let me change the color of my pen. Alright, now I'm going to go back to this because this is simpler. We could go back in and plug it into this equation and see if we have a true or a false. But I'm going to plug it into this, and I'm going to go ahead and put my symbol back. It's a little easier to work with this simplified version. So I'm going to plug in, let's see, we chose 3/4. So 2 times 3/4 is 6/4. And 6/4 minus 1, this number is bigger than 1. So when we take away 1, we're still going to have a positive amount. So we have a positive number on the top, and then we'll plug in 3/4 here. 3/4 now is less than 1. So when we plug that in, we're going to get a negative number, and a positive divided by a negative is a negative. So these solutions here are going to be negative. I just need to kind of mess that up a little bit. So we just need to find out what kind of numbers we have. Alright, I'm going to choose a number over here, and I'll use 2, and then plug in 2. 2 times 2 is 4. 4 minus 1 is a positive 3. And then put your 2 in here. 2 minus 1 is a positive 1. Positive divided by a positive is a positive. So our solutions here are going to be positive. Now we're looking for numbers that are less than or equal to 0. And the only ones that are going to make that true are going to be our negative answers. So all of these numbers in between 1/2 and 1 are going to be part of that solution set. We're going to include 1/2 but exclude 1. So the way that we write that, when we include a number, we use that hard bracket. So it's going to be 1/2 to 1, and then we use a parentheses, or I'll call it a soft bracket, to show that we're not including that. So let's see if we can find that solution up here. Alright, let's go on to the next one, and we're going to break this apart, and then I'm going to let you stop and then think about what we're trying to answer before we move on. Alright, we're going to be solving the same kind of inequality. We want the solution to the rational inequality 6x squared minus x is less than 2. What is the first step? What was the first thing that we did in that last problem? Did we factor? Did we move everything to one side? Did we find critical points? Did we test the values from each of the intervals in the number line? So what was the first step? Go ahead and pause here and then make a guess, and we'll come back and answer. Alright, our first step is going to be to move everything to one side. So we're going to start by subtracting 2 from both sides, so that we'll have 0 on the right. And on the left, that 2 doesn't combine with anything. So we'll have 6x minus x minus 2 is less than 0. This time it's not less than or equal to, it's just less than. Alright. Now what is the solution to this rational inequality? When we've taken that first step and we moved everything over to one side. What's the second step? Would you factor, move everything to one side? I think I'm going to eliminate that because we've already done that. Find critical points, test values from each intervals on the number line. So pause for a minute, make your best guess, and then move forward. Alright, the next step is to factor. Once we have everything on one side, you would factor it. This is a trinomial. And I'm going to go ahead and use bottoms up factoring. And I'm going to start by taking that coefficient of the middle term, -1, put it up here. And then I'm going to multiply the coefficient of the first term and the constant in the last term. So it's going to be 6 times -2. Put that down at the bottom. So that's -12. Okay, now I want the factors of -12 that add to give me that middle term, and that coefficient is a -1, if you remember. I'm going to point to it right here. Remember, that's a -1x. Alright, so I can factor this into 3 times 4, and in order to multiply together, one of those needs to be negative. So we'll start with -3 times +4 is a -12. But do they add together? When we add them together, -3 plus +4 is a +1. I'm looking for a -1. So let's switch the signs, 3 and -4. They still multiply to give me a -12, but now when you add them together, you get a -1, which is what we're looking for in that middle term. Alright, so we're going to put the 3 here and the -4 here. Now you can switch sides. It doesn't matter which side you put which number on. And then we're going to go back to this leading coefficient, and we're going to put that underneath each of these numbers. So we'll have 3, 6, and we'll have 4, 6. Right now I'm going to reduce each fraction. I can reduce 3, 6. They're both divisible by 3 to 1/2. And 4 and 6 are divisible by 2, so this becomes -2/3. So now we have what we need in order to pull it into our two binomial factors. Okay, so we're going to look at this reduced fraction, and we'll start with the denominator. It's going to be 2x, and then we have a +1 on the top. Now I'm going to go over here. We're going to start with the denominator, and we'll have 3x, and then if you look closely, I didn't put that negative here, but it's a -2 on the top. So it's 3x minus 2. Now let's just check our factoring. First terms, 2 times 3 is 6. X times x is x squared, so that checks. And then do your outer and your inner terms. 2 times -2 is -4x. And then 1 times 3 is a +3x. When you add those together, you get a -x, which is our middle term, so that checks. And then our last terms, -2 times +1 is a -2. So this is the way that you factor. So we have it factored correctly. All right, now that we have it factored, and let's go back and look. I already forgot what I wrote. 2x plus 1, 3x minus 2. 2x plus 1 3x minus 2. Now, depending on when we did our factoring, we can change the order of these. So look carefully for that answer. I'll give you a minute to pause and see if you can find it, and then enter your answer. Just double check your factoring to make sure that you have it done correctly. Alright, so if we change those sides, we have 3x minus 2 times 2x plus 1. Okay, so the answer is C. Alright, now that we have it factored into 2x plus 1, let me go ahead and write that down again. we'll set that factor equal to 0. And the second one was 3x minus 2. We'll set that equal to 0 as well. And then solve for x. What are the critical values that need to be plotted on the number line? Alright, so pause, take a minute, solve each equation, and then make your selection. Alright, let's go ahead and work through this. In that first equation, we'll have 2x. If we subtract 1 from both sides, we get 2x equals negative 1. And then divide by 2, x equals negative 1/2. Alright, there's one critical value. Now let's look at this second part. Start by adding 2 to both sides. And then you'll have 3x equals 2. And then divide by 3 to get x equals 2/3. Alright, so those are your two critical values. Let's see if we can find that answer. X equals 1/2 and x equals 2/3. Oh, it's negative 1/2, so this is going to be A. Go slowly, make sure that you keep an eye on your negatives and your positives. Don't drop anything. Alright, so the next step is going to be to plot those on a number line. And because we're not including equal to, leave those circles open. And then just draw these lines right here to divide this into 3 areas. Area A, Area B, and Area C. And then we'll plug in a value that's hopefully easy for us to work with. So I'm going to pick negative 1 and plug it in here for x. So we have negative 1 squared gives us a positive 1. Positive 1 times 6 is 6 minus negative 1. So that's going to be the same as adding 1. So is 6 plus 1 less than 2? And the answer is no. Positive is not. Yeah. Positive 7 is not less than 2. Alright, now I'm going to go to the middle, plug in that 0. We're going to get 0 times 6 is 0, minus 0 is 0. Is 0 less than 2? Yes. And then go to the the third area. Alright, pick a number on the right. I had to drink some water. Okay, now pick a number in this area. We're going to pick 1 to make it easy. So 6 times 1 is 6 minus 1 is 5. Is 5 less than 2? And the answer is no. Alright, so our solution set is going to be in between here. All of these numbers are going to make that inequality true. But we're not going to include negative 1/2, so we have that soft bracket or that parentheses. And we go to 2/3. And we have that parentheses. So this is how we write it in the correct notation. So it's going to be area B. Alright, now we have it already graphed, and we know that it's this area that's going to check true for our solution set. How do we write that? Do you remember? Alright, go ahead and pause and make your choice, and then we'll come back and see if we're correct. Alright, we're going to be using parentheses instead of hard brackets because negative 1/2 and 2/3 are not included. Alright, we don't have separate sets. It could be this set and this set united, so we'd use the union symbol. But we only have these, so we've only got one set that we need to notate. between negative 1/2 with those soft brackets to 2/3. And that is our solution, and it's going to be A. Alright, now we have another function. We want to name any x and y intercepts in the graph of the function. So if you remember, we start by factoring, and we have everything over on one side, so we'll begin by factoring. Now, if you have a certain way to factor, or if you don't feel real confident with factoring, you can use Math Papa factoring calculator or any factoring calculator to factor. But I start by factoring out a 3, and then I'll factor the rest into negative x minus 2 times, I think the tricky part's going to be factoring, times x plus 1 times x minus 1. And you set that equal to 0. Now your x-intercepts are going to be where each of these factors is equal to 0, because that will make a true statement. So negative x minus 2 equals 0. We need to solve that. X plus 1 equals 0. We need to solve that. And x minus 1 equals 0. Okay, so I'll just work backward in reverse. Here we have x equals 1. Here we have x equals negative 1. And here we have negative x equals 2. When we move that 2 over to the right, now divide through by a negative 1, or multiply both sides by negative 1, and we'll get x equals negative 2. So here are your x-intercepts. Alright, so if you remember, we factored and we had x equals negative 2, and we have x equals 1, and we have x equal negative 1. Now those are our x-intercepts. Those are the zeros of our function. Oops, let me get my pencil back again. So what that means is we have our x coordinate, our y coordinate is going to be 0. We also have 1, 0. So we have 3 places that it's going to cross or touch the x-axis. And then we have negative 1, 0. Those are 3 points on our graph. So write that down. We're going to need that in a little bit. Hold on to that. Okay, where is our y-intercept? The y-intercept is where we substitute in 0 for x and solve for y. If we substitute in 0 here, we have 0 times 0. That makes this term 0. Same thing here. 0 squared is 0, times negative 6 is 0, and 0 times 3 is 0. So 0 plus 6 is 0. So when x is 0, y is going to equal to 6. So this is our y-intercept. Alright, there's one more thing that we need to look at. We need to look at this first coefficient, or this first term. Look at the coefficient first. It's negative, and the power is odd. Negative and odd. Now, if you remember, I sent you notes and asked you to keep those handy. This is the end behavior of our function. So let's just go back and look again. Negative and odd. So let's find that on our chart. Odd and negative. So where those two meet are right here. So it's going to be rising in the second quadrant, and it's going to be descending in the fourth quadrant. So our behavior is going to look like this. All right, we'll take that into the graph. Remember, it's going to be rising here and descending here. And if you wrote down what I asked you to write down, and please take notes, keep those handy so that you can complete this part of the test. Taking notes is important. So when we factored, our x-intercepts are -2 and 0. So I'll plot that point. I'm trying to keep my pen from going away. Right, there's -2, 0, -1, 0. These are really close together. Apologize. And then 1, 0. And then we also have the y-intercept at 0, 6. Okay, because I know what the end behavior looks like. I can start up here. It's going to go down. It's going to come back up. It's going to go through the y-axis here, and it's going to go back down here. All right, so you just connect the dots to plot that. Take a minute to let that sink in, and then we'll move on to the next. All right, now we want to graph this function. This is our last one. So let's put everything together. We're going to start by factoring. We have everything on the right, so we need to factor the numerator. And from the numerator, I can factor out an x from both of those terms. So I have x times x minus 3 over, and then factor the denominator. When we factor the denominator, I can use that bottoms up method or whatever method you use to factor, and we'll get 2x plus 3 over x minus 3. Okay, look carefully, and we see that we have an x minus 3 in the numerator and in the denominator. So anything over itself is going to just be 1. So we can cancel that out. But we also have to use that to identify the whole in our function, and that's going to be at x minus 3. So if you set x minus 3 equal to 0 and solve for x, you'll get x equals 3. Plug that back into the equation with that whole taken out, or with that 1 taken out, and just look at the x, substitute in 3, and the 2x plus 3, substitute in a 3. 3 times 2 is 6, plus 3 is 9. And that's 3 over 9, or that reduces to 1/3. So when x is 3, y is 1/3. That's where your whole is going to be. Okay, so I can go ahead and plot that. I'm going to go over 3 and up 1/3, and then just draw a hole in here. It's not going to be real exact, but just try to get it close. Alright, there's our hole. Now the horizontal asymptote, we look at what's left over and we take the coefficient of whatever that x is on the top. The coefficient is 1, and the coefficient of the x term on the bottom, that's 2. Okay, so now that we've done that, we have our, let's go ahead and plot that y equals 1/2. So here's where y is 1/2. Just make a dotted line. I made that circle a little bit big. It looks like it's going to run into it. It's really not. Okay, but that's where our horizontal asymptote is, at y equals 1/2. Now let's find our vertical asymptote if we have one. Alright, now that's going to be where the denominator equals 0. So we'll go back to our denominator and we'll set that equal to 0. And we'll solve for x. So x is equal to, we'll move that 3 over to the right, and then we'll divide by 2, so x equals -3/2. Probably should have made a bigger graph. Okay, but we'll make that dotted line. And that tells us where we're going to approach and get close to, but never cross. Okay, so it's going to look like this. It's going to go like this. And just make a rough sketch. It's going to go like this. Alright, and that's how you sketch the graph. Just a reminder about what we've learned in behavior. If you look at these two functions, we're looking at this leading coefficient, and we're looking at our chart, if you remember. Okay, odd or even, positive or negative. Alright, that leading term, we have a negative and an even. So if we use our chart, negative and even is going to be right here. It's going to go down and down. So we interpret that in words. As x approaches negative infinity, what happens to the y? It's going to approach negative infinity as well. Okay, just some more practice with interpreting this chart. Alright, now it's time for you to do your part. Go into Nearpod, take your notes, answer these questions, do your best. You don't have to tell me when you're done. I'm going to update these grades on Thursday, and hopefully everybody has 100. You can always go back and watch the recording, but do your best. Our unit tests are important as far as your grades go.